Hello, this is Scholar Strife doing some math today in geometry. We're going to prove triangles are similar by AA. So the angle-angle triangle similarity postulate says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So all we need to do is show if we have a triangle here and a triangle here. We just need to show two angles are similar, are congruent to show that they're similar. So that was A, B, C, D, E, F. If we show angle A is congruent to angle D, and angle B is congruent to angle E, then the triangles are similar. Now the reason why we don't have to show the third angle is congruent is because a while back we showed if two angles of one triangle are congruent, then the third one has to be congruent. Right here, all of the angles will be actually congruent by the third angle theorem. Shadow problems in direct measurement. Basically, they use the sun shining on two nearby objects. So let's say if we had a person here, and then we had a tree. Let's make a better tree. There's the stump. And then we have maybe little apples or oranges. But basically, they use the sun, and if it's shining on two nearby objects, it uses their shadows and their heights we can use those in order to find the height of tall objects, like the tree here. So, example 1, are these triangles similar? If so, write a similarity statement. Okay? So both of these triangles have right angles. Angle B is congruent to angle E. But they tell you that angle D is 22 degrees here, and then angle C is 68 degrees. Those don't match, but they're not supposed to. We need to see if either angle A is congruent to angle D, or we need to see that angle C is congruent to angle F. And how do we do that? We're missing the angle. So if I look at just triangle ABC, we need to remember that there is 180 degrees total in any triangle. So if angle B is 90 and angle C is 68, we can find out what angle A is if we set it equal, if we add them all together and set it equal to 180. So I'm going to subtract 90 and 68 from 180, and we'll get 22. And notice here that angle A is the same thing as angle D. And if you did it the other way, you'll find out that angle F is also 68 degrees. So yes. So we're going to say triangle ABC is squiggly or similar to triangle DEF. Alright, now they want us to show that the triangles are similar. You can redraw the triangles separately if needed. Okay, so what they mean is, in this left picture, there's two triangles. There's the big triangle, and then there's the small one near the top of the pyramid there, if you think of it that way. So I'm just going to redraw it. So here's our TV and RQS. Now both of these are 49 degrees. And angle R is congruent to itself. They both share the same top there. So those angles are the same. Therefore, that they are similar by AA, double A. Angle, similarity theorem. Alright, so then we have these two triangles. So they tell us that this angle here is congruent to that angle. And they tell us that those lines are parallel. So what do those lines being parallel mean? Okay, it means... So if I redraw, so here's the two parallel lines. And then we have a transversal, if you remember from last semester. This angle here is congruent to this angle. And if I redraw back the triangles, you can see that these two angles are also congruent. So angle MNL is congruent to angle OPM. So by double A, these two triangles are similar. Alright. So they give us angle C is a right angle, angle F is a right angle. So we have angle C is congruent to angle F. And then we just need to find one more angle. If you remember from first semester, if we have an intersection, that means opposite angles are also congruent. So if we have an intersection, opposite angles are the same. So angle CDB is congruent to angle FDE. So by double A, these two triangles are similar. Alright, a flagpole casts a shadow that is 50 feet long. Okay, so here's our flagpole. And it casts a shadow that's 50 feet long. At the same time, a woman standing nearby who is 5 feet 4 inches so we got a woman here, 5 feet 4 inches. So 5 feet 4 inches is 5 feet 4 inches. How many of that inches? 5 times 12 is 60. So this person is 64 inches. And they cast a shadow that is 40 inches long. Inches. How tall is the flagpole to the nearest foot? So basically what's going on is we're going to be using the idea of similar triangles. So let's redraw the flagpole again. So we have the height, and then we have a 50-foot distance here. So I'm going to change this to inches so we're all in the same unit. 50 times 12 is 600 inches. Okay, So this is 600 inches, and this is what we're looking for. We're looking at the top of the flagpole. Now if we just connect these two, we have a triangle here. And not only, we have a right angle there. And then we're going to do the person, the woman here, 40 inches, and then 64. And that's also going to be the right angle. Now we are able to use the fact that these two triangles are similar because these two triangles are similar, we can find the height of the flagpole using a person's height and length of their shadow. So let's say I want to know the height of the flagpole, and we're going to compare that to the height of the person and set that equal to the length of the flagpole's shadow, which is 600 inches, over the shadow of the person, which is 40 inches. And when you do cross multiplication, you'll get 40x equals 38,400. Divide by 40, and you'll get x equals 960 inches. Or, you can convert that back by dividing by 12, 80 feet. And the reason why the triangles are similar is because they have the right angle, and this angle is basically the sun shining down on them, casting that shadow. So a lifeguard stands beside a lifeguard chair on the beach. The lifeguard is 6'4" tall. So let's go ahead and change that 6'4" to 76 inches. And then the chair casts a shadow that's 6 feet long. So that's 72 inches. There's 12 inches in a foot. The chair casts a shadow that's how tall is the chair. And so we're doing this the same way. So let's do height of the person. Over height of the chair. Equals person shadow over shadow of the chair. So height of the person is 76. Height of the chair is, we don't know. Length of the shadow of the person is 48, and then 72 for the chair. Do our cross multiplication, we'll get 48x equals 5,472. Divide both sides by 48 to get x is 9.5 feet. Half a foot is, this will be 114 inches. Kind of skipped ahead. And if you convert that back into feet, that's either 9.5 feet, or you can say 9 foot 6 inches. Alright, hopefully this helped you out. Have a good day.